All right, so for our second day of review, we are focusing predominantly on that section 1.6. And this is kind of a big part of your test, so you do want to make sure you know how to solve these. The first two are a little different than the second two in that they have an exponent that is a rational number, right? A fraction. It still means that we're taking a root, but we're also raising it to a power. The key to solving these is to isolate the thing that's being raised to the rational exponent. Okay, so on the first one here, let's add the 10 to the other side and divide out the 5. We want to get x to the 7/2 by itself. And then to undo a 7/2, we have to raise it to the reciprocal power. So the reciprocal of 7/2 would be 2/7. So we are going to raise both sides to a 2/7 power. For this answer, the left side just reduces down to plain x. But on the right side, we have 2 and it's getting squared, and then it's having a 7th root taken, or a 7th root taken and then being squared. Because the question was written with a rational exponent, we're fine with you leaving the answer that way. So you can leave this as 2 to the 2/7. Another option would be to go ahead and do the squaring and put it as 4 to the 1/7. But 4 is not a perfect 7th, so we can't break that down at all. All right, for the second question, the whole side is being raised to a 1/3 power, which really means it's being cube rooted. So to undo a cube root, we have to do what? We have to cube it. So we're going to cube both sides. So we have 5x minus 1. It was cube rooted and now we cubed it, so we've gotten rid of that power. On the right side, what is 4 to the 3rd power? Okay. And now it's just a linear equation to solve. So add our 1 over and divide. I do want to caution you a little bit when you have roots like this. If when you do the reciprocal power, you're ending up with an even root, you have to include plus minus. For example, if I had something to say a 2/3 power, okay, equaling a number, to undo a 2/3 power, I would need to raise it to a 3/2 root. Sorry, to a 3/2 power, which means we are square rooting, right? The 2 in the bottom is the root. And so in that case, I would have to put the plus minus in front of that. Okay. All right, our second two questions are dealing with radical equations. So instead of the root being written as a rational exponent, we actually can see the root. Okay, it says a radical notation. To undo this side that has a square root, we would need to square both sides. When I square the left side, I simply get the 5x minus 4. When I square the right side, I end up with 16. Add our 4 over and divide. It's really, really important that you guys check your solutions, because if you list something that really doesn't work, it would be marked wrong. Okay, so let's plug it in and check it. Does the square root of 5 times 4 minus 4 equal 4? Well, 5 times 4 is 20. 20 minus 4 is 16, and the square root of 16 is 4? Okay, so that is the correct solution. Yes. All right, the question was, is there times where you do all the work right and you still get the wrong answer? Or you get an answer that doesn't work? Yes, it is possible. Typically, it happens when we end up with two solutions. A lot of times one works and one doesn't. Especially when you end up with expressions on the other side that's not just a number. Okay. For question 4, we're going to square both sides. Be careful on the right side here. How do we square a binomial? Our left side, just we have gotten rid of the square root, but what do we get on the right side? Think of taking x plus 2 times itself, or following that pattern. Square the first term. Yep, twice the product. And square the last term. Since I have x squareds on the right side, I'm going to move everything to that side. So I'm going to subtract a 12x over here, and I'm going to add a 12. And how does that factor now? Close. Yep. So this really becomes x minus 4 times x minus 4, or x minus 4 quantity squared. So what are my solutions? Yeah, they're both 4s. All right, again, let's check it. We're going to put a 4 into both places. 12 times 4 is 48. Minus the 12 is square root of 36 is 6. So the one side gives me a 6. If I put 4 on the other side, 4 plus 2 also gives me 6. So it works. All right. Our next questions, the next two, are what we referred to as quadratic form. All right. Number 5 is not quadratic. It's a 4th power. It's a quartic expression. However, it kind of fits the same quadratic form that we've been factoring. The form requires that the power you have here is twice as big as the power you have there. All right? If you see that, then try to think in terms of factoring. Pretend it's just an x squared. But instead of an x squared, we have an x to the 4th. So instead of an x in each one, we need an x squared in each one. And then can you picture multiplying insides and outsides and getting some x squared terms? Okay. To divide up the 36, we want it to multiply to be 36, but add up to negative 13. Okay. Negative 9, negative 4. Now, what do you notice about those? Can they be factored more? Yeah, we have difference of squares here. So x squared minus 9 would factor into x plus 3 and x minus 3. And x squared minus 4 would factor into x plus 2 and x minus 2. So what do I end up with for solutions? Okay, so positive and negative 3 and positive and negative 2. Okay. Question 6 is again one of those quadratic forms. It looks much more complicated, and the common thing that students want to do is they start foiling out the first part and distributing the negative 11. You don't have to do that. It's actually in a better form right now than if you did the other. You have a quantity that's being squared. You have that same exact quantity as your middle term. So just like an x squared gets split up into one x in each one, we're going to split this up and have an x plus 1 quantity in each one. And then can you picture insides and outsides are going to create these x plus 1 groups? What multiplies to be a 30 and adds up to negative 11? 5 and 6, both of them negative? And now we can do some simplifying. We have x plus 1 minus 5, so this is really x minus 4. We have x plus 1 minus 6, so that's really x minus 5. So my solutions would be 4 and 5. All right, I'm going to pause the video for a second, let you guys ask some questions about that. All right, question 7 has 4 terms to it. What's the technique we had for factoring with 4 terms? What pattern did we have? What? If we did have a greatest common factor, we definitely would want to pull that out first. It starts with a G. Factor by grouping. Yep. So let's get everything to one side. And then with factor by grouping, we want to look for something common in the first 2 pieces. What's common in the first 2 terms? A 4x squared, we'd have an x minus 3 left over when we divide that out. Okay, what's common in the second set? So we'll take out a negative 9. I'm going to make it a negative 9 because that leaves me an x minus 3, right? And the leftover part, these things have to match for the grouping technique to work. So one of my factors will be 4x squared minus 9. And the other factor is this common x minus 3 piece. Four x squared minus 9 is a difference of 2 squares again. So how would we factor that? Yep. All right, so what are my solutions? Three over 2 and negative 3 over 2 and positive 3. All right. Our last question is the fun one, right? Where you have 2 square roots in the expression. Our technique was to isolate one of them first. Usually we try to isolate the more complicated one first and get it cleaned up right away. So I'm going to add this square root over to this side. So I have the square root of 2x minus 3 equaling 1 plus the square root of x minus 2. I then have to square both sides. And the left side cleans up nicely. The square cancels the square root, so we have 2x minus 3. The right side is typically where students make mistakes. So be really careful. If it helps you, take 1 plus the square root of x minus 2 and write it out twice in FOIL. Okay? 1 times 1 is 1. Outside's going to give me a 1 square root of x minus 2. Insides is also going to give me 1 square root of x minus 2. So I have 2 square roots of x minus 2. And then the last piece, the square root of x minus 2 times itself is just squaring it, right? So the square root goes away and we just get the x minus 2. All right, let's clean that up a little bit. We've got a 1 and a negative 2, so that's negative 1. We've got an x, and we've got these 2 square roots of x minus 2. Anything that doesn't have a square root on it should get moved to the other side. So I'm going to add a 1. I'm going to subtract an x. All right. At this point, if you could divide this 2 to the other side without creating fractions, I would do it. Since I can't do it without creating fractions, I'm going to leave it there. We still have a square root that we have to cancel by squaring. And whatever I do to one side, I have to do to the other. How do I square an x minus 2? Okay, again, write it out twice and FOIL it if it helps you. On the right side, I have to be careful because there's a 2 in front here that has to get squared to become a 4. It's being multiplied to a square root that will cancel when I square it to be an x minus 2. So I end up with 4x minus 8 on that side. From here, we're going to subtract everything to one side, or I should say move everything to one side. X squared minus 8x plus 12. And now I can factor. What factors am I looking at here? Okay, both negative. So possible solutions are 2 and 6. And then we definitely would want to plug these back in and check them in the original equation. So it's really common when you're getting 2 answers like that, that one of them doesn't work. Okay? Because class is almost over here, I'll just tell you they do both work. So I would include them. But on a test, I would definitely check them. Okay? So we plug them back in to the original equation. If I could get it to scroll up here. So I'd have to plug them back in for x in the original problem. All right, work on day 2's review.